Good morning all, this is Joita Moitri, and yes, I am back with my fourth episode from Fun to Explore series from thermal physics, and today we will be talking about session 5, which is transfer of thermal energy. So this chapter we basically studied about three important processes, which is conduction, convection, and radiation, and today we will basically explore something new about these processes and all. So before starting, something we always have to remember, that is heat transfer always occurs from hotter region to colder region so that they can actually reach to a state of thermal equilibrium. Thermal equilibrium is basically a state when there is no difference in temperature. So all this heat transfer always occurs basically so that they can reach to a state when there is no difference in temperature. At least there is something I like about thermal physics, that is thermal equilibrium. They're at least trying to reach towards equality. It's such a good thing. Oh, thermal physics, I like something about you. Alright, so yes, let's move on to review the three different processes a little bit, and then we will start with our fun explore. Alright, so the first process we have is basically conduction. And the next one is convection, and the last one is radiation. So I have basically explained why, how, which, what, everything, when, basically why they occur, everything in session 5. You can check it out if you have some confusion, but still I will just review the main points. So conduction, we have studied the equation or the formula for calculating the rate of heat transfer for each of these processes. So for conduction, it is Q by T, which is rate of heat transfer, is equal to Ka del theta, wait, what? Okay, cut. Ka del theta by L. Sorry. Okay, so rate of heat transfer through conduction is Q by T equals to Ka del theta by L. And we all know conduction occurs in solids. Please remember that conduction can occur in one solid between the two regions which have a difference in temperature for one solid, and also between two solids which are in contact with each other. So conduction will occur in two situations, one solid or two solids that are in contact with each other. Now convection, it is Q by T, which is rate of heat transfer, is proportional to A del theta, and it can occur in liquids or basically gas. And radiation is Q by T is proportional to AE T power 4, and it can occur in air or basically vacuum, anywhere. So we discussed in detail about each of these processes through session 5. Now what is even there to actually explore new from all these things? I at least don't find anything from this stupid, boring, irritating chapter. Sorry. But yes, I have a question to you all, that is, what happens basically, how do we feel the heat? When we touch an object, suppose I touch an object or substance, how do I feel basically, why do I feel the heat? Why do I feel hot? Is it due to the hot, high temperature of the object, or is it due to the rate of heat transfer from the object to my hand? Well, of course, the rate of heat transfer from the object to my hand, and the process is conduction. Two solids in contact with each other I am touching, so conduction. So speaking of conduction, we can see that rate of heat transfer through conduction basically increases when K, conductivity increases, A, surface area increases, del theta, difference in temperature increases, and L, length, decreases. Very simple. Now let's take del theta. So we understand that if there is no del theta or no difference in temperature, then heat transfer through conduction will never take place. And also it is the same for convection, because there is also del theta. I kind of like radiation because radiation does not care about del theta and difference in temperature. It only cares about T, which is temperature of own. Much like teenagers, they don't care about other people. Alright, good. So yes, so we now understand that if there is if the difference in temperature is less, then the rate of heat transfer is less, and I will feel less hot. And if the difference in temperature is more, then the rate of heat transfer will be more, and I will feel more hot. That is the thing. So it's all about difference in temperature and the rate of heat transfer, not about how high the temperature is. Now let's move to another interesting doubt. That is, suppose the difference in temperature is less. Okay, rate of heat transfer will be less. Simple. No. Well, rate of difference in temperature is less, but conductivity is more. Look at the equation. Rate of heat transfer is less. Difference in temperature is less, but conductivity is more. And since conductivity is more, that is why despite the difference in temperature is less, still the rate of heat transfer will be more, because conductivity is more. And I'll tell you one interesting information, that is, no object in this universe have a conductivity of 0. Every object has conductivity more than 0. And that is why you can confidently say that if there is a difference in temperature, then heat transfer through conduction will definitely take place, because conductivity is always more than 0. So yes, that is it about conductivity and all. And coming to conductivity, we all know that metals are better conductors than the others. And we all have discussed about metals and free electrons and all these things in session 5, and it was real super fun. So here is one interesting example, because till now we have studied everything mathematically using theories and all these things and equations and all. But it's time to test that these theories are actually a part of our everyday life. You'll ask how? Let's take example. In winter, you will notice that suppose you touch the door to open it, you'll notice that the metal doorknob is colder than the wooden door. Why is it? Well, because metals, they are better conductors than wood, which is not a conductor, insulator. So since metals are better conductors, they will conduct or take away the heat faster, or basically the rate of heat transfer from my hand to the metal doorknob will be more than the rate of heat transfer from my hand to the wooden door. And since the rate of heat transfer is more, that is why, since I am losing heat faster, that is why the metal doorknob will seem to be much more colder than the wooden door, despite both of them are at the same temperature. Interesting, right? Well, speaking about conductivity, we all know that conduction mostly takes place in solid, and liquids and gas are very poor conductors of heat. Yeah, heat. Okay. Okay. So we also have an example for this. Okay, we all have seen how oven works, right? So suppose if you give something in the oven to heat it, you will see that after it is heated, when you take it out of the oven, you will notice that when you put your hands in the oven to take it out, you will not feel that much hot. It's fine. But the moment you touch the bowl, which is containing the hot substance, you'll be like, ouch, so hot. So that is the thing. That is actually helping us. You see, it's an advantage, because the air inside the oven, it is not a good conductor of heat. That is why the rate of heat transfer is not so much, and that is why I am not feeling the heat in my hand. It is not affecting me. But the moment I am touching the bowl, it is the bowls, since they are solids, they are better conductors of heat, and that is why the rate of heat transfer is more, and that is why I am feeling the hotness. So you see, these are so interesting things. Well, you must be thinking, whoa, conduction, it is so joss. It must be the fastest process of heat transfer. Nah. Okay, so this is the question. Which process is basically the fastest for heat transfer? It's not conduction. It is in fact radiation. Because radiation, infrared radiation, they basically travel with the speed of light, that is 3 into 10 to the power 8 meter per second. And coming to convection, in convection we all know molecules move and transfer heat. So which is faster than in conduction, where molecules basically heat transfer occurs to molecular vibration and all. Molecules, they cannot move. So although conduction is very joss, it is the slowest. It is very disappointing, I know. Alright, so actually I talked about convection, right? Convection actually reminded me of something very interesting. That is, you know, in convection we know that, let's take the example of air. We all know that hotter air, it is lighter, and since it is lighter, it rises up, and then the colder air being denser, it sinks down, and all this blah blah blah, and heat transfer occurs through convection. So my question is, for how long will this hot air keep rising up, rising up, rising up, and rising up? For how long? Will it just keep on rising up, rising up, and rising up, and then die? No. Basically what happens is, here is an interesting thing. When the hot air keeps on rising up, rising up, and rising up, it basically, on its way to rising up, it loses heat. And since it loses heat, the temperature decreases. And as temperature decreases, the volume also decreases. Church's law. And since volume decreases, density increases. And since being more denser, it is now no longer light to rise up, and rise up. So it levels off. And that is why you will notice that even in the road we sometimes notice smoke, right? Smoke rising up. You will notice that the smoke keeps on rising up, but at a certain point it doesn't rise up anymore. It just rises up till a certain point, and after that it doesn't rise up anymore. That is the point it becomes dense, and then it just levels off. It doesn't rise up again. Alright, so all this interesting thing is done. I hope it was interesting and cool. I'll just end with one last example. That is, suppose there is a fireplace. So how will you feel the hot if you keep your hand beside the fireplace? Process. Which process? Of course, radiation, because it is occurring in air. And you know why I looked into the camera like with that weird face? Because there was a machi on my mom's hand. That's why my mom was laughing, and that's why I got a little weird. Okay, machi, don't disturb my mom. Alright, so basically, how will I feel the hotness? That is radiation, because it is air, and it is not convection, because convection of heat always occur in upward direction. And so now if I keep the hand upward or up of the fireplace, it is of course convection, but another process also occurs, which is radiation. Why? Because radiation of heat transfer all occurs in every direction. It's not only upward or this direction, it occurs in every direction. And with that, we are done with our episode 4 of Fun to Explore series from thermal physics. And yes, I'll be back with the next 5th episode from Fun to Explore, which will be our last episode from thermal physics, and after that, I'll be not with you anymore, with thermal physics. And yes, one last thing, that is, I have, all of you I guess already know, but in case you forgot, I have already announced a contest, writing contest from my blog, which is Explore Page 1, and this is honestly my request from the bottom of my heart, that is, please participate. Anyone from the age 10 to 19 is eligible to participate. The deadline is 30th June. And please participate, because I eagerly want to read all of your writings, because I'm superbly bored. And if I say my parents that I'm bored, they just tell me, read books, study. I'm like, who feels to study in the vacation? Like, they don't understand. That's why I say parents are hopeless case. But anyways, please participate, and yes, stay home, stay safe, and stay cool, and thank you.